Hey folks, welcome to your first flipped lesson for Algebra 2. It's going to be on section 1.4 in your ebook about solving absolute values. Before we get started, whenever we have a flipped lesson, you should have some sort of note-taking guide from class that I've given you. This will walk you through all the examples we're going to be doing together. So as I'm doing my lesson, you should be taking notes, and this is really what's going to be part of what's due next class, okay? Before we get started, I want to tell you about the reason why I do flipped lessons. Flipped lessons are pretty cool, if you think about it. In class, you're spending all of your time listening, trying not to be distracted by anyone else, and feverishly writing down notes. In math, that's hard because if you miss one step or something, you're kind of lost for a second. The reason why a flipped lesson in math is awesome is you can pause me whenever you want, okay? You can rewind if you didn't hear something, and you can put in your headphones and not be distracted by anyone else. So instead of our time being spent with you taking notes in class, our time together will be spent with you practicing this stuff. Okay, making sure that you have it right and asking me or a peer or someone else that's in the classroom for help if you need it, okay? Or for clarification so you know if you're doing it right or not. So that's kind of the reasoning behind why I do flipped lessons. I'll do them every once in a while. And I hope that, you get something from it. So, you're going to get something from it now. Pull out this note sheet. Make sure you follow along with me. We'll just get started. So like I said, we're going to be talking about solving absolute values. And before we do that, we really should define absolute value. I know you've probably worked with them before. Maybe you recognize the symbol for absolute value, the absolute value bars. But you might not remember necessarily that absolute value is a measurement of distance from whatever number is inside your bars all the way to 0. Okay? So absolute value is the distance, and number is from 0. Now, because it's a distance can never really be negative. Okay, you might think, oh, we're going backwards, it would be negative. It's not really. It's still a distance that you're traveling. We'd still add it on top of how far you traveled, so it's positive. And that's why the outcome of absolute value must always be a positive number. Okay? Many of you probably are like, okay, absolute value. If I saw absolute value of -5, I know I just take the negative away and I make it 5. Well, that's because -5 is 5 jumps away from 0. Okay? Likewise, if you had something like 13 minus 3 in absolute value bars, these being your absolute value bars, okay? You would do that math inside. You get the absolute value of 10. The distance that 10 is from 0 is 10 jumps. So again, it's the same number, and you just make sure that it's positive. So distance from 0, pretty much all you do is take whatever's inside, simplify it down, and make it positive. We're going to look at two things with this. We're going to look at solving, which involves finding what n equals, and we're going to look at evaluating. And evaluating is really just plugging in a value and being able to solve equations using order of operations that also involve our absolute value bars. So let's take a look at that one first, okay? These really are the easier because as long as you know your order of operations, you should be good to go, okay? So again, this is an example on your sheet right here. Follow along, write some notes, and we should be good to go. So, looking at this problem, I see that I do have a variable n. They tell me what n equals. Obviously, my first step is going to be to take this value and plug it in. Okay, that's what we always do when they give us some sort of value. So I'll have 8.4 minus 2 times negative 7.5 plus 5, all in absolute value bars. So, as I go about solving this, I'm going to treat my absolute value like it's parentheses, okay? I'm going to solve everything inside of it first using my order of operations to make sure that I get my correct solution. So I have multiplication and addition. I'm going to first solve this multiplication. Negative times a positive is a negative. 7.5 doubled. Well, 7 doubled is 14. Half doubled is 1. So negative 15 plus 5. Now I'm just going to solve this piece down. Negative 15 plus 5 is negative 10. Okay. Now that there's nothing else in here except for a number, again, just like if it's parentheses, I'm going to use my absolute value bars. Now is the only time that I'm going to take whatever's in there and make it positive. I don't do it here and I don't do it in this step. I do it only, again, I do it only when there's a number in there, an integer, a whole number, or some sort of rational number with no other work around it, okay? So here, I'm going to solve this piece and rewrite it one more time. This negative 10 in absolute value bars becomes a positive 10. This negative outside is still there. That just comes right down. And then the 8.4. Now my last step is to do the subtraction. 8.4 minus 10 is going to be a negative 1.6. So you can see here, my solution to this whole equation here is a negative number. That's fine, okay? The only negative that I have to correct is whatever and if it's the number left inside my absolute value bars. Same thing as order of operations. Simplify what's inside when you get it down to a single number, make it positive, plug it back in, and solve everything on the outside using your order of operations again. Okay? There's a few of these on the back, I think 4 or 5, that I'm going to want you to try. Okay, attempt. They tell you what the letters equal at the top. So try your best on those. Remember, order of operations. It's really not that bad. Harder than evaluating absolute values is really solving them. When you have a variable, you don't know what it equals, and you need to find out what it equals. Okay? Now, absolute value problems are kind of interesting. Normally, we're used to an equation. We solve it through, and we get one solution. Right? Okay, we just did rational and radicals. You always get one answer with those. Okay? Well, here, sometimes we get 2 solutions, sometimes we get 1 solution, and sometimes we're only going to get an extraneous solution that we find by checking. Just like with square roots, you have to check it. Same thing with absolute values. We're going to start off by looking at 2 solutions and kind of talking about why 2 solutions and how it could even happen. So let's talk for a second about the absolute value of some number equaling 5. Okay? So in your head right now, you should be thinking, and I bet you can think of it, what 2 values inside here equal a positive 5 after we apply our absolute values? Well, one of them is the number 5, right? The absolute value of 5, if we plug it in here, would equal 5. But there's another solution, negative 5. If we take this negative 5 and plug it in for x, the absolute value of negative 5 would equal 5. So you can see that our x is going to have 2 solutions. Now, it's not always the positive and negative version of the number, okay? But keeping this in mind helps us set up our problem so we solve it correctly. Let's look at an example here, and we'll try to list out some steps maybe that you can use for all absolute values, okay? The first thing you want to do, just like when you're solving with radicals, we just did that, okay? You want to isolate your absolute value bars, okay? So you're going to look at the side that has your absolute value on it. You're going to ask yourself, is there anything going on outside these bars on this side of my equal sign? And our answer here is no, okay? Now, we're going to see examples later where we have a +3 or a ×2 in front. Right now, we're going to work easier to harder, okay? A little bit easier. After you have isolated your absolute value bars and everything that's going on inside, after that's the only thing on one side of your equation, then you're going to split your equation into 2 pieces. If you think about it, this x plus 12, okay, could be 9, right? I could have the absolute value of 9 inside here, and that would give me the solution. It could be positive 9. But this x plus 12, we'll write it right over here, could also equal what inside this parentheses? Inside here, the answer could be a negative 9, right? So this chunk, inside our absolute values, could be negative 9. So when we split it into 2 parts. One that is a positive solution that you have over here, and one that is the negative version of this same solution. Because when we plug the negative in to our absolute value, it's still going to be positive. It won't matter, okay? After we've done this, we're just going to solve each piece, and those are our 2 solutions. Here, I would subtract 12, I get x equals negative 3. Here, I'm going to subtract 12, I get x equals negative 21. Okay? They're 2 very different solutions. We're going to plug them in to check, okay? Extraneous solutions do exist here. Right now, we're going to not have to worry about that. But we're going to check it anyways because you need to get in that habit, because if not, you're going to have answers that don't work if you don't check them. So in my head, I'm thinking I'm plugging in negative 3. Negative 3 plus 12 is positive 9. Absolute value it, it's 9. Perfect. Negative 21 plus 12 is negative 9. Absolute value my negative 9, it's 9, it works. They're both good. Okay? So my solutions here are x equals negative 3 and x equals negative 21. Now we can write that as a set of answers. I don't know if you've done this before. I did it with my Algebra 1 last year. Is a set is put in curly brackets, and you usually put your smallest number first, and then a comma, and then your larger number, okay? And this means there's a set of answers that could work. Negative 21 could work, and negative 3 could work, okay? Again, it cannot be parentheses, or it's going to look like a coordinate pair. It needs to be these nice curly brackets, 2 solutions. So we isolated our absolute value, or checked, this one already was. We split it into 2 parts. One part was our positive answer, one part was our negative answer. Our third thing we did is we isolated our variable. Okay? And then lastly, we put our 2 solutions in set notation. Okay? Let's try to start incorporating this versus putting x equals negative 3 and x equals negative 21. All right, let's look at this example. Follow our steps, get it down. See if we can find our solutions. Okay. Again, when we solve, we're finding what our variable equals. So I'm going to isolate my absolute value bars. I look at this side of the equal sign. There's nothing going on outside those bars, so it's already pretty simple for me. Next, I'm going to split it into 2 parts with a positive answer and a negative answer. So I'm going to split it. I'm going to have the positive answer, 8, equals y plus 5. Okay, my inside could be a positive 8. My inside here could also be a negative 8 because the absolute values will make it positive. So negative 8 equals y plus 5. Ooh. Okay? Now, I'm going to just isolate my variable, solve it like it's a normal equation. I'm going to subtract 5. Subtract 5. I get 3 equals y. Here I'm going to subtract 5, subtract 5. I get negative 8 and negative 5 is a negative 13 equals y. Okay? I'm going to check them. After I check them, I'm going to put them in my set notation. Okay? So 3 plus 5 is 8. Absolute value of 8 is 8. Yay, it works. Negative 13 plus 5 is negative 8. In the absolute value bars, makes it positive. Oh, that works too. Good. So in my set builder, I'm going to put negative 13, comma 3. Those are my 2 solutions that work for this. Okay? Isolate my absolute value bars, split it into 2 parts, get my variable by itself, check it, and put it in set notation. We just looked at a couple examples that when we solved the absolute value down for our variable, we got 2 solutions, okay? Here, we're going to solve these, but something different is going to happen, all right? Let's do what our normal steps were before. Our first one was to get our absolute value bars by themselves, okay? So we're going to look over here where our absolute value bars are. Is there anything going on outside those bars? Yes, right? We're multiplying here by a negative 2. So I want to get rid of that. I want to isolate it so it's just this chunk with this piece that I'm going to try to solve, all right? To get this, multiply by negative 2 gone, I'm going to divide by negative 2 and divide by negative 2. Those cancel. I'm still left with the absolute value of 3a, equaling a positive divided by a negative is a negative. 6 divided by 2 is 3. Okay? Now, this point, right now, I know that this is a no solution situation. And you're probably saying, can't we just split this, do 3a equals 3 and 3a equals negative 3? And you would normally think that. The thing that makes this different than our other one is that before we apply these absolute values, if we look at our solution, it's already negative. So think about that. Can the absolute value of anything ever be negative? We just talked about absolute value being distance. Distance isn't negative. By definition, absolute value means make it positive. Well, we can't. It's negative. So you stop here and you write no solution. Okay? This can happen pretty often. It can happen when you're dividing. It can happen over here. You'll see we're going to subtract. We're going to get a negative 8. Okay? So here I look at this side. I'm saying to myself, all right, I need to isolate my absolute value bar, so I need to get rid of this plus 8. I'm going to subtract 8. Okay? I'm going to have absolute value of 4b plus 1 equals negative 8. I want to split it right now. Okay? I'm thinking in my head, I'm going to split it, make one positive, one negative. But before I do that, this says the absolute value of something must equal a negative, and that's not possible. Okay? It's a no solution situation. There is no answer that when you apply the absolute values to, you will get out a negative. No solution. Okay? So that's a nice quick way to look at problems and solve them. Always keep it kind of in the back of your head. If your answer, okay, over here, once you get your absolute values by themselves, is negative, before you split it, don't split it, just write no solution. Save yourself some time. Now, if you did split it, okay, so let's just kind of walk through this and see what could happen. Say I have 3a, I'm like, okay, 3a equals negative 3, 3a could equal 3. Divide by 3, divide by 3, divide by 3. Okay, I have a equals negative 1, and a equals positive 1. Now, when I go to plug these in to check my answer, okay, so this is why checking is also important in case you forget that rule. I plug in negative 1, I get negative 1 times 3 is negative 3. Make it positive. It should be positive 3, but it's not. Okay? If I take this 1 and I plug it in, and I go, okay, 1 times 3 is 3. It's an absolute value bars. Make it positive. It still doesn't work. Okay? So if you go back and check this, even if you accidentally split it, okay, if you go back, check your answers, you're going to see that your signs aren't going to match up. No signs will match up at all if you have a negative over here right before you split it. Okay, here it was positive, but when we isolated it and made it negative, that stops us and prevents us from ever getting a solution that will work. So we've looked at situations where we get 2 solutions. We looked at situations where you plug them in and you check and you get no solutions whatsoever. There are times where you could get 1 solution, and there are times where you get 2 solutions, but it's going to look really messy. Okay, so this one's going to yield 1 solution, and we'll talk about why. But this is about how complicated they're going to get. Okay, these are not always going to be those nice one-step problems that we were just looking at. Sometimes they're going to be gnarly. We're still going to follow the same steps we were just talking about. We're going to look. Okay, we're going to ask ourselves, looking at only the side that has absolute value, we're going to ignore over here, is my absolute value alone? And clearly it's not. You've got to multiply by 2 and you have an x that is being subtracted from it. Okay, so we're going to take care of this now. We are not going to take care of the 2 quite yet. All right, I'm going to first take care of this x. I'm going to take care of it by adding it to each side. Now I'm left with 2, absolute value of x plus 1, equals 3x plus 1x is 4x, minus 4. Now I have this 2 to contend with, okay? I need my absolute value to be alone. I need to get rid of this 2. So you're thinking, and I know many of you probably already wrote it, to get rid of a times by 2, I'm going to divide by 2, and then over here I'm going to divide everything by 2. It's like the distributive property with division, okay? Those cancel. Now I'm where I want to be, x plus 1, okay, in absolute value bars. But over here it becomes something a little bit more funky, all right? Over here, we're going to have 4x divided by 2, which is 2x, and then a minus 4 divided by 2, which is a minus 2. So just to recap, for those of you who might not know how to distribute that division well, what I did is I took that and I said, all right, I divide that by 2 and I must divide this piece by 2. And then just simplified it to each chunk. Okay? If it helps you to write it as separate pieces, then go for it. If you can just put it as a divide by 2 underneath and you know to divide each piece by 2, do it whatever way works best for you. So now that I'm here, I can take this right here and I'm going to do the exact same thing I did before. Now remember, when our absolute values are isolated, I take our solution, I make one solution positive and one solution negative. All right? Here, I'm going to have my x plus 1 equaling the positive solution, which is the same exact thing here. Okay? That's one way to split it. The other way to split this is to take our x plus 1, and now we need it to be the negative answer of this. So I'm going to put a negative in front, a negative 1, and I'm going to be distributing it to each chunk. Okay? Which once you get good at this, I'd start by writing this step, but once you get good at it, you'll see, it just changes this sign and it changes the sign of your second piece in your binomial. Okay? So we'll have x plus 1 still, but now we're going to have minus 2x plus 2. I'm going to hop back over here. We're going to solve this one down. It's easier. So I'm going to move my x's all to the same side. I'll subtract x. I'm left with 1 equals, 1x minus 2. I'm going to add 2, I get 3 equals 1x or x. So that could be one of my solutions. I'm going to go back and check it afterwards. Now I'm going to come over here. Again, I put the negative because I needed a positive solution. This is our solution, even though there's x's there. And I needed a negative version of our solution. Our solution still has everything that's on this side of the equal sign. When I applied the negative, I had to put it to both pieces. Now I'm going to do the same thing I did over here. I'm going to move my x's all to the same side. This time I'm going to add 2x to get 3x plus 1 equals 2. I'm going to subtract 1, subtract 1. I get 3x equals 1. Divide by 3, divide by 3. Which leads me to the solution, x equals 1/3. Last step, check it and put it in set notation. So to check this, I'm going to plug in my 3. You can plug it in here, you can plug it in here, you can plug it in here. It doesn't matter which of these versions you plug it into, as long as it's the one that has the absolute value. I usually plug it into this because it's the easiest one. It has the least work on the absolute value side. So if I plug in my 3 to check it, I would have 3 plus 1 is 4. Absolute value of it is 4. Equals, now over here I should get 4 also. 3 times 2 is 6, minus 2 is 4. Oh, yay, it works. Okay? Now I'm going to check my 1/3. That's a little bit more challenging. But we've reviewed how to multiply fractions and things like that. So 1/3 plus 1 is 1 1/3. In absolute value bars, so make it positive. So on this side of my equation, I have positive 1 1/3. I want to get the same thing over here, okay? So if I do 1/3 here, I plug that in. 2 times 1/3. Actually, I think I'm going to write this one out. 2 times 1/3 minus 2. Well, that, I would do that, go across the top and across the bottom. I get 2/3 minus 2. If I do 2/3 minus 2, I would have negative 1 1/3. Are these two things equal? No. One is positive, one is negative. That means that this solution is extraneous. We know extraneous means a solution that will not work. It's not possible. Okay? An extraneous solution is found here when you plug it in and your two sides do not match each other. Okay, we plugged it in. We got the positive version, the negative version. This is extraneous. So the only solution we have here is this. So in my set notation, I would put just the number 3. And that's my solution. Let's do one more of these really hard ones, just to make sure that we have a little bit of experience under our belt. And again, we're only going to get one solution in the next example, too, when we go back and plug it in. All right, last problem we're going to do together that you're going to have to put in your notes. We look here. We're told to solve it, so we need to figure out what x equals. First step, just like every other time, is get my absolute value bars alone. So looking at this side of my equal sign, I see there's a lot of stuff going on. I want to take care of it now. So to get my absolute values alone, I'm going to start by getting rid of this chunk. Instead of a minus 2x, I'm going to add 2x to each side. Now I'm left with 3 times the absolute value of 2x plus 2 equals 3x plus 3. Again, I look over here. It's not alone yet, so I'm not going to split it yet. I'm going to get it alone by dividing by 3 and dividing everything over here by 3. Those cancel. Now I have absolute value of 2x plus 2 equals 3 divided by 3 is 1x plus 3 divided by 3 is 1. Okay, I'm just going to erase that one. Who use that placeholder? I don't. Now I look, absolute values alone, and now I split, okay, into 2 pieces. One piece has my answer, 2x plus 2, and then this piece over here is positive, x plus 1. This split is going to still be 2x plus 2, but over here I have to make it my negative. Okay, so I'm going to put a negative 1 that I distribute to this entire side, x plus 1. Okay, I'll hop over here, solve this one down. It's nice and easy. I don't have to worry about the distributive property. I'm going to subtract x. I get x plus 2 equals 1, minus 2, minus 2. X equals negative 1. I'm going to check it in a second. I'm going to hop over here, distribute my negative 1. So I get negative x minus 1 with my 2x plus 2 in front. Now I'm going to move my x's to the same side, add x. Those cancel. And I'm left with 3x plus 2 equals negative 1 minus 2 minus 2. I have 3x equals negative 3. Divide by 3, divide by 3. And I'm going to get x equals negative 1. There's my other solution. Now look what happened this time. I got the same answer. I'm going to check -1 in here, make sure it works. And if it does, I'm not going to write it twice. I'm just going to write it once. -1 should work for both our positive and our negative version, which seems strange, but let's see why. Let's go here. Okay, I'm going to check my -1. So I have absolute value, you can see that there, of 2 times, not x anymore, we're going to plug in our -1, should equal x plus 1. Oops, I'm not putting in x, I'm putting in a -1. So solving this down, 2 times -1 is a -2 plus 2, still in our bars. -2 plus 2 is 0. The distance from 0 to 0 is 0, okay? So that's on one side of our equal sign. And then -1 plus 1, well, that's 0 too. So I've checked it, it works. My solution now is -1, and I'm not going to write the same number twice. So now that you've seen a couple complicated ones, you've seen ones that give you 2 solutions, absolutely no solutions, and then ways that extraneous solutions can come up so you only have 1. I'm not going to actually have you do the practice all on the back. If you look at it, I want you to just try to do the first 4 problems where you plug it in and solve, but don't worry about these ones below. We'll do those in class. Looking, it looks like this video is already going to be about 20 minutes. I don't want you to spend much more time on your homework, so get those 4 done right here across the top where you're just evaluating, and we'll worry about practicing solving these in class. If you feel ambitious and you want to try them. But if you don't, and you're already at your tipping point, just bring your notes with you to class, completed, filled out, and the 4 problems at the top. Thanks, guys. I will see you next time I see you.